In this video, I'm going to show that each of the three elementary row operations can be expressed by a matrix. Basically, you multiply these special matrices on the left of the given matrix to perform the elementary row operation. So for this video, I'm only going to be using this 3x4 matrix. The concept is exactly the same for any size matrix. The first thing is, let's suppose we want to interchange row 2 and rows 3. You should always think about starting off with the identity matrix. That is, modifying the identity matrix. Okay, we modify the identity matrix and we're going to get what we want. For the record, what we want is row 1 not to change, row 2 to become row 3, so A31, A32, etc. And for the third row, row 3, to become what the second row was. This is what we want in the end. Now, regardless of what row that is that I just boxed, when I dotted with the first column, the second column, the third column, the fourth column, or if you prefer, if I multiply this by the entire matrix, I am going to get row 1. I am going to get this. If I dot this with this matrix, I'm going to get row 2. And since this is in row 2, I'm going to put row 2 in the second position. When I dot this with the matrix to the left, I'm going to get the third row. I'm going to get the third row. And since this was the third row, I'm going to put the third row here. But wait a minute, I don't want the third row there. What we're going to do is just interchange row 2 and row 3 of the identity matrix. Like I said before, when we multiply or dot this row with this matrix, we're going to get the third row. But since this is row 2, I'm going to put the third row of this matrix here in the second row. And when I dot this row here with this matrix, I'm going to pick up the second row. Now, since this is in row 3, my answer, this row, it goes into row 3. To interchange row 2 and row 3, start off with the identity matrix and interchange row 2 and row 3. If you had a bigger matrix and you wanted to interchange row 5 and row 9, and start off with the appropriate identity matrix and interchange row 5 and row 9, and everything will be fine. Let us look at the next elementary row operation. We want to say multiply rows 3 by R. Okay, So basically, we want to take this matrix, multiply it by something in the left, and only row 3 is being changed. So I want to get back row 1. I want to get back row 2. And I want to get back r times row 3. That is, each of these entries get multiplied by r. Oops. They all get multiplied by r. So I write down the identity matrix. Since I'm not changing row 1 or row 2, I'm not going to modify this at all. Now, I want to get back, when I multiply the third row by this matrix, I want to get back r times the third row. Well, let's consider the first column. 0 times that is 0. 0 times that is 0. So far, the sum is 0. Well, if I want to get r times A31, that better be an r. So I got back the first entry correct in row 3. The second column entry. 0 times A12 is 0. A12. 0 times A22 is 0. Oh, look at this. Plus r times A32. That's exactly what I wanted to get back. Third column. 0 times A13 is 0. Plus 0 times A23 is 0. The sum is 0. Plus, look at this. R times A33. That's just what I wanted to get. No difference in the fourth column. 0 times A14 is 0. 0 times A24 is 0. Their sum is 0. Plus r times A34. 0 plus 0 plus r times A34 is r times A34. Got just what I wanted. Work like a charm. Let us consider the next elementary row operation. I want to add, well, let's say r. I want to add a multiple of one row to another. I want to add r times row 2 to row 3. So only row 3 is changing. Just because I'm adding a multiple of row 2 to row 3 doesn't mean that row 2 is changing. So the last row is going to be row 3 plus r times this. It's going to be row 3, A32, plus r times that, r times A22. It's going to be A33 plus r times A23. The last entry is going to be row 3. Let's try to clean that up, please. It's going to be A34 plus the multiple of row 2. It's going to be A34 plus r times A24. And the other two rows, nothing's going to happen to them. A21, A22, etc. Okay. So like I said, you want to modify the identity matrix. Whether or not you want to write down the identity matrix, that's up to you. But since row 1 isn't going to be changed, that is, row 1 in the product is still row 1. That means you want to have 1, 0, 0, row 1 of the identity. Since row 2, I multiply this matrix by this matrix, and I get back the same row 2. So that means I should have 0, 1, 0. But then it changes. When I multiply the third row by this matrix, I'm supposed to get this mess. But if you notice, I do get, among other things, row 3. That is the first entry from column 1 is there, entry from column 2, entry from column 3, and entry from column 4 is there. So it makes sense that I have a 1 here. But now I keep adding on multiples of R2, row 2. There should be an A23 there. See if I have enough room to fix this. It's going to be A33 plus R times A23. Okay. So since I'm adding on row 2, I got a column 2 on my identity matrix. And this is where I put my R. And this is going to work like a charm. If you look at column 1, 0 times A11 is 0. Then I get R times A21 plus 1 times A31, which is exactly this. And then I get, when it comes to column 2, I get 0 times A12, which is 0. There's my R times the second entry, R times A22 plus A32. Same deal with the third column. I get 0 times A13, which is 0. Get R times the second row plus the third row. Exactly what I wanted. And the same exact game with the fourth column. That is how you add R times row 2 to row 3. All I did was I went to row 3 because that's the row I wanted to change. I'm going to add something. I don't care for the next moment what I'm adding to row 3. But I'm adding to row 3. So I go to row 3 and then I modify it. I want to still have row 3. I'm still going to have row 3. But I want to add R times row 2 to it. So I go to the second column and I put my R there. Let us write down all the answers again, and then maybe we'll look at a more complicated problem. If you just want to interchange two rows, just say row 2 and 3. Just interchange row 2 and 3 of the identity matrix. If you want to multiply a row by some multiple, instead of having a 1 for that row, if you want to multiply row 3 by R, put an R there. If you want to add a multiple of one row to another, if you want to add a multiple of one row to another. In our case, we want to add to rows 3. So I'm going to change rows 3. And since I'm adding R times row 2, I go to column 2 and I put an R there. Okay, and if you think about why, it all makes a lot of sense. Give me a moment, please. If I take this matrix and I multiply it by this matrix, hold on a second. If I multiply it by this matrix, well, row 1 and row 2 are going to be fine. They're just going to be the same. Now, when you multiply this by this matrix, or if you dot it with the first column, you're going to keep getting R times that, and you're still going to get the A31. So you're going to get R times A21 plus A31. Same game with the second column. The 0 is not going to contribute anything. And look at this. Row 3 is going to have R times the row 2 entry plus the row 3 entry. You're going to have R times A22 plus A32. Same game for the third and the fourth column. So this, let's get rid of this arrow. This matrix corresponds to that. Needs to start being really clear, like, yeah, this is how you do it. Let's do one big one. Suppose you want row 1 to become 3 times row 3, and you want row 2 to go to row 3, and you want row 3 to become row 1. Let us see how you can do this. So, yep, I knew that was going to happen. So we have our beginning matrix. This one right here. Let's try this one last time. Okay, so we have this matrix. Why won't it say copy? Okay. Maybe I'll put it down here. So we have this matrix, and we want to multiply it by something, and we want to get back for row 1 3 times row 3. So this is row 3. I'm going to get 3 times it. 3A31, 3 times A32, 3 times AC3, and 3 times I meant to say A33, 3 times A34. And row 2 is supposed to become row 3. Okay, well, this here is row 3. That is row 3. And we want that to become row 2. Okay, A31, A32, A33, and A34. And row 3, we want it to be A1. Okay, A11, A12, A13, A14. This is what we want. Now, rows 3, let's go. I like to do the interchange rows first because they're easy. I want rows 3 to become row 1. So I put the normal row 1 identity there. And I want row 2 to become row 3. So instead of row 2, I put the identity for row 3. But now I want row 1 to become 3 times row 3. A little bit different. So row 1 should become row 3, but 3 times it. This will do it. When I multiply this row by this column, the only non-zero entry is going to be 3 times A31. Exactly what I wanted. And when I come to the second, it's going to be 3 times A32 and 3 times A33, etc. And then when I dot the second row with the first column, it's only going to pick up the last entry because I had 0 plus 0 plus A31. And when I dot it with the second column, I'm going to get 0 plus 0 plus A32. Exactly what I wanted. The third column, 0 times A13 plus 0 times A23 plus 1 times A33. Same thing for the fourth column. I'll get A34. And then if I multiply this matrix, let me get rid of this because I drew on it so much. When I multiply this third column, third row, with the first column, I'm only going to get A11 as a non-zero entry because 1 times A11 is A11 plus 0 plus 0. Same thing with column number 2. I get A12 plus 0 plus 0. A12. Third column, I get 1 times A13, which is A13, plus zeros. Last column, only gonna pick up the A14, because 1 times A14 is A14, plus 0 times A24, plus 0 times A34 is A14. I got the right answer. Believe it or not, this matrix, namely 003, 001, 100, this matrix did these 3 elementary row operations. I was able to make one matrix that did all 3 of them. Though one might argue that replacing row 1 with 3 times row 3 with not an elementary row operation. I could add on row 1. And if I did that, then all that changes is a 1 goes here. All that would change is this value would become a 1. That way, I pick up row 1. I'll have plus A11 plus A12 plus A13 plus A14. Okay, that completes this video. Please leave comments telling me how much you hate my videos. I really like reading those comments. Or you can leave comments saying how much you enjoy my videos. If you want me to make up a video showing a proof, let me know what proof you like to see. And most of all, watch and learn. Thank you.